Here's another example, and this time we want to solve for x. I don't see any logs, but I do see x's in exponents, so I will need to use logs in order to solve for x to get it out of this exponent. And at first glance, this looks kind of tricky because I've got an exponential of the base 8, an exponential of the base 4, and I'm subtracting a couple terms. This looks kind of weird, but we have to be kind of clever and recognize that I can rewrite these things as powers of themselves. And so really we have to recognize that 8 is the same thing as 2 to the third power. And I have to recognize that 4 is the same thing as 2 to the second power. So I can rewrite both of these quantities as powers of 2. So this actually becomes 2 to the third to the x power minus 5 times 4, oh, I'm sorry, not 4, x minus 5 times 2 squared to the x power equals 0. So I basically just rewrote 4 as 2 squared, 8 as 2 cubed. And I can simplify this to say that this is 2 to the 3x minus 5 times 2 to the 2x, and that equals 0. So it looks, I guess, same base, but this still might be kind of complicated. So really what we have to do here is now this is almost, imagine like we are factoring. I want to see, I've got two terms, and I want to see if there's a common factor between the two of them. And if I think about what 2 to the 3x is, 2 to the 3x means 2 to the x times 2 to the x times 2 to the x. You add your exponents, and 2 to the 2x is the same thing as 2 to the x times 2 to the x. Well, what I see right here is I've got common factors right here, and then both of these are 2 to the 2x. So essentially what I've shown here is that I can factor out a 2 to the 2x from both of these terms here. So let's see what that looks like, and let's switch up my colors here. So this is going to equal 2 to the 2x. I'm factoring out that common term, and what's left over is a 2 to the x minus 5, and that equals 0. So now I use my zero product property. I have a product of two numbers, and it equals 0. 2 to the 2x could equal 0, or 2x, or 2 to the x minus 5 could equal 0. Now I know that I can't ever get this expression equal 0, so I'm going to cancel that one out, just cross it off. I don't care about it. And here I get 2 to the x equals 5. This is a nice, easy exponential equation I can solve for. This all becomes in logarithmic form as x equals log base 2 of 5. And you notice this says solve for x exactly. This is an exact solution. As long as I can write this in logs, that's exact. If I were to punch this into my calculator and round a decimal, that's an approximation. I want to leave it just like this. Kind of a tricky problem, so why don't you try this one with the same strategies we did last time. Look for a common base, look for exponential terms that you can factor, and give this one a shot. All right, and here's my solution to this one. I wrote everything with a base of 5, factored out 5 to the x, and I came out with x equals log base 5 of 3.